All right, so here we are, the very first ever created Edpuzzle video lecture for chemistry. Done a lot in biology, but this is my first ever with chemistry. I'm sure you're very excited. I think it's about 12 slides. I'll try to make it go as quickly as possible. Remember, there are going to be questions coming up, and this is worth points. So if you're not taking notes, better have a good memory. All right, hope you enjoy it. All right, so structure of the atom. This really should be pretty easy for you guys. For most of you guys, it'll probably be some review. But man, some will be new. All right, so the structure of the atom, all matter. So the stuff we're made out of, our clothes, things in the air, everything's made out of atoms. Atoms are the smallest unit of an element that still has the element's properties. So you can keep dividing something like, say, you have gold. You can keep dividing it down, dividing it down. It's still gold until you get to an atom. Now you can break it down further, but it'll no longer be gold. And atoms are made of the subatomic particles called protons, which have a positive charge, neutrons, which have no charge or neutral charge, and electrons, which have a negative charge. And right here, you can see this is the atom of carbon. So you can see in here in the nucleus is where the protons and the neutrons are at. And then flying around in different energy levels or different shells, these are the electrons that are orbiting around the nucleus. Okay, still structure of the atom. So remember that we just did this. So it's kind of review from the last slide. Remember the three subatomic particles that make up atoms. Protons, those are found in the nucleus right here, the middle of the atom, the protons that have a positive charge found in the nucleus. And it's the number of protons which gives you what's called the atomic number. So you can see here's oxygen right here, an oxygen atom. And oxygen has 8 protons. That's its atomic number. If it had 7 protons, it wouldn't be oxygen, it would be nitrogen. If it had 9 protons, it wouldn't be oxygen, it would be fluorine. So the atomic number of oxygen is 8 because that's the number of protons it has. Remember, also in the nucleus, you have their neutrons, which are neutral or no charge, found in the nucleus with the protons. Together with the protons, it gives you what's called the atomic mass. So it's basically kind of like what the atom weighs, how much mass an atom contains. And almost all the mass comes from the protons and the neutrons because the little electrons are tiny. The protons and neutrons, they're small too, but compared to the electrons, they're much larger. And remember, floating around, flying around, orbiting the nucleus of the atom are the electrons that have a negative charge, and they're found in different energy levels or different shells. So you can see here, oxygen in its inner shell, the first shell only holds 2 electrons, and it's got 2. So that inner shell of electrons, that first orbital, is full with 2 electrons because that's all it holds. The second one out here can hold 8. And you can see here, oxygen has 6. 1, 2, 3, 4, 5, 6. So that outer shell of electrons for oxygen is not full. These are called valence electrons. We'll go over it later. Valence electrons, all atoms want to fill the outer shell of electrons. So oxygen makes a lot of compounds. It combines with other things, like it combines with hydrogen to make water. The only reason it does that is because oxygen wants 2 more electrons. 1, 2. It wants 8, because if it gets 8, that outer shell will be filled and the atom will be more stable. All right, so that's the structure of an atom. All right, this will be quick because I basically went over all this already pretty much. All right, so remember the nucleus is in the middle, contains the protons, which are positively charged, and the neutrons, which have no charge or neutral. Remember, this contains almost all the mass of an atom, almost all the weight, almost all the matter is contained in the nucleus. Remember, flying around in different clouds or shells or different energy levels, you have the electrons. So here's the first energy level right here. It holds 2 electrons and it's full because that's all it holds. Here's the second energy level. It holds 8. Oxygen only has 6. So it wants 2 more electrons in order to fill that outer shell, which are called the valence electrons. So the electrons in the outermost shell, in this case, oxygen has 6 of them. Those are its valence electrons. And those are the electrons that are going to be used in chemical bonding. So it's those electrons that when it meets up with hydrogen, 2 hydrogens, the oxygen and the 2 hydrogens, they share electrons so that they can both fill their outermost shell. So when oxygen combines with 2 hydrogens to form water, H2O, it shares 2 electrons. So then it fills its outer shell of valence electrons, giving it 8 instead of 6. So it's the valence electrons that determine the chemical reactivity of an element. It's what gives it all of its properties. Does it react with other elements, or does it not? All right, so that's structure of an atom again. Okay, atomic number. Remember, all that is the number of protons in the nucleus of an atom. And that atomic number is what defines the element, because each element has a unique atomic number. They have a unique amount of protons. So here we have carbon. So this is where you're going to start, in the periodic table, you're going to see like different numbers and different symbols. The C is for carbon. That's the symbol for carbon. 6 is its atomic number. That means it's got 6 protons. Doesn't necessarily have to have 6 neutrons. Remember, atoms of carbon have to have 6 protons, but it can vary the number of neutrons. And then down here you have the atomic mass, which is basically how much matter in atomic mass units that the element contains. Over here we got oxygen. It's got a different atomic number. Its atomic number is 8 because it has 8 protons in its nucleus. Its symbol is an O for oxygen. Then here's its atomic mass, which we'll go over. I'm going to go over, I think, on the next slide. All right, so remember, the atomic number is just the number of protons that an element has. And it's always, so for carbon, it's always 6. Because if it's 7, it's going to be nitrogen. If it's 5, it's going to be boron. Carbon always has 6. Oxygen always has 8. All right, another key term is going to be really important. Isotopes. Isotopes. These are atoms of the same element, but they have different numbers of neutrons. So right here, you can see oxygen right here. Oxygen 16 has 8. Oxygen always has to have 8 protons. That's what makes it oxygen. It wouldn't be oxygen if you had 7 or if it had a different number of protons than 8. It's got to have 8. But the number of neutrons can vary. Oxygen 16 has 8 neutrons. 8 plus 8 gives you oxygen 16. Oxygen 17 still has 8 protons, but it's got 9 neutrons. 8 plus 9 is 17. Its mass number is 17. And there's also oxygen 18, still with 8 protons, but oxygen 18 has 10 neutrons. So its mass number, which is protons plus neutrons, would be 18. So like carbon over here, you have carbon 12, 6 protons, 6 neutrons. You could also have carbon 14, still has 6 protons, but now it has 8 neutrons. So isotopes, same element, but they have different numbers of neutrons. Okay, 2 more key terms. Mass number and atomic mass. Okay, we already went over atomic number, which is probably the most important one. It certainly will be. Atomic number is the number of protons that an atom has in an element. So the number of protons, that's its atomic number. Its mass number is the protons plus the neutrons. So for carbon 12, its mass number would be 12 because 6 protons plus 6 neutrons gives you a mass number of 12. Now the atomic mass, remember that's how much mass an atom has, but it's the weighted average because remember, there are different isotopes. So like there's carbon 12, there's carbon 13, there's carbon 14. Now almost 99% of all the carbon is carbon 12. And a little over 1% of the carbon on Earth is carbon 13. And virtually hardly any of it is carbon 14 because carbon 14 is what's called radioactive and it'll decay and become a different element. So the atomic mass of carbon is 12. That's the weighted average. They take the average of all the isotopes and then they come up with the average, and that's the atomic mass. Okay, atomic mass unit, real quick. You can't use things like pounds or even grams to describe the mass of an atom because they're so tiny. So a pound, you can't use it because pound is too big of a unit. Because look, if you used grams, the size of like a proton or a neutron would be 0.00023 zeros and then 16605. So that's just too small. 0.23 zeros and then a couple numbers, way too small. So they came up with what's called the atomic mass unit. It all has to do with carbon 12. So they gave carbon 12 and they just made it have 12 atomic mass units. So basically, 1 AMU is this. This is scientific notation. I don't think you'll need to know this. I'm 99.99% sure you will not. 1.6605 times 10 to the negative 24th grams. All right, but its approximate mass, 1 AMU, is equal to approximately the mass of 1 proton or 1 neutron. Because they're like, a proton and a neutron, their atomic mass is like 1.00000 and then a couple numbers. So 1 AMU is roughly the mass of a proton or a neutron. And the mass of an electron is tiny. So you can see how much smaller. So a proton and a neutron would be 1 AMU, where the electron is 0.0005 AMU. All right, so you can see hydrogen here. It is the smallest, its atom is the smallest of all elements because its AMU is 1. And most hydrogen on Earth, over 99%, it doesn't have any neutrons. It's just got 1 proton and 1 electron. All right, so that's atomic mass unit. All right, so we got nuclear reactions and then the different types of radioactive decay, and we'll be done. All right, so nuclear reaction, it's changes in an atom's nucleus, so not just the electrons. So usually when we're talking about chemical bonding and chemical reactions, we're talking about the electrons because those are what are going to interact with other atoms. It's the electrons that are interacting with each other to make new compounds and chemical reactions. But a nuclear reaction changes the nucleus of an atom. So here we have uranium-235. It's used in a lot of different atomic bombs. It's also used in nuclear power plants to make electricity. So this is where a neutron strikes a large nucleus of the atom uranium-235. So 235, that's its mass number. 92 is its atomic number. So uranium has 92 protons. All right, so when that neutron strikes the nucleus of a uranium-235 atom, it takes that neutron in and it's unstable. It has to break apart. And it does. And in this case, it's splitting into 2 smaller atoms of barium-139 and krypton-95. So when it does that, when the large uranium-235 splits into 2 smaller atoms, that's called nuclear fission. And in the process, when the large atom splits into 2 smaller ones, it releases a lot of energy. So that energy can be used to make electricity. So nuclear fission is a large atom breaking into 2 smaller. Nuclear fusion is when you have 2 smaller atoms that squeeze together to make a larger one. So fission is splitting apart. Fusion is coming together to become bigger. Then we're also going to go over radioactive decay and the 4 different types. So you have alpha decay, which will be the next slide. You have 2 different types of beta decay, beta minus and beta plus. Beta plus also called positron emission. And there's also gamma radiation. All right, so we'll go over these and then we'll be done. All right, the types of radioactive decay, radioactive elements, they decay in order to become more stable. So the first one's alpha decay. So right here we got uranium again. This time it's a different isotope because remember on the previous slide it was uranium-235. This time it's uranium-238. So it's got 3 more neutrons than uranium-235. All right, so in this case, all you got to do is know what are the products, what gets emitted in this type of radiation. And an alpha radiation, it emits what's called an alpha particle, which is this guy right here. And all an alpha particle is 2 protons and 2 neutrons. So it's basically the nucleus of a helium atom. Helium has 2 protons, 2 neutrons. So it gives off 2 protons and 2 neutrons. That's called an alpha particle. So since it's losing protons and neutrons, well, the protons is making it change to a different element. So look, uranium started with 92 protons, but once it gave off the alpha particle that has 2 protons in it, now you got a new element because now it's only got 90 protons, and that's going to be the element thorium. And you can see here, remember the mass number was 238. So 238, that means you add all the protons and neutrons, you add them up, you'll get 238. But since we lost 2 protons and 2 neutrons, that mass number is going to go down by 4 to 234. All right, so that is alpha decay, where you get off an alpha particle, which is 2 protons and 2 neutrons. It's very low penetration, so it's not dangerous outside the body. It can be stopped by a piece of paper. But if you inhale it in or it gets inside the body, then it can cause damage. All right, I'm not sure you're going to need to know this, but get it in your notes anyway, just in case. All right, so we got 2 types of beta decay. The first one's beta minus. All right, so we're going to make new elements here. One element is going to be converted into something else. And right here, beta minus is the top picture. So we start with carbon-14. Carbon-14. 14 is its mass number because it's got 6 protons and 8 neutrons. 6 plus 8 is 14. The mass number is not going to change after this decay. But what happens here, a neutron in the nucleus turns into a proton. So we started with 6 protons. That's what makes it carbon. Carbon always has 6 protons. But since 1 neutron turned into a proton, it went from 6 to 7 protons. Carbon doesn't have 7 protons. Nitrogen does. So when one neutron turned into a proton, it gave it 7, which made it now nitrogen. And its neutrons went from 8 to 7. But still, look, the mass number is still 14 because 7 plus 7 is still 14. The only thing that changed, we added one more proton. That's why it went from carbon to nitrogen. In the process, it emits what's called a beta particle, which is this, an electron. An electron shoots out, and also an antineutrino. Just to get that in your notes, it's kind of just something to kind of memorize. All right, the other one's called beta plus, also called positron emission. And it's like the opposite. Instead of a neutron turning into a proton, this is where a proton in the nucleus changes into a neutron. So this time we got carbon 10 as our example. So carbon always has 6 protons, but in this case, one of the protons turned into a neutron. So it went from 6 protons to 5. So since it now has 5 protons, it's no longer carbon. It's now boron, a new element. And you can see since one of the protons turned into a neutron, the neutrons went from 4 to 5. So we added one more neutron because one of the protons turned into a neutron. All right, so in this case, you give off a beta plus particle, which is this right here. It's a positron. It's an electron that has a positive charge, and it also gives off a neutrino. Are you going to need to know neutrino and positron? I'm not sure, but you're going to need to know basically what beta decay is. So where the atomic number increases by 1 in beta minus, and then atomic number decreases by 1 in beta plus. So it goes from 6 to 5 in beta plus, and up here in beta minus, the protons went from 6 to 7. All right, so that's beta decay. All right, the last type of radiation in our last slide, up to about 15 or 17 minutes or so. In college, that'd be like the shortest lecture in history. High school, it's like, oh, it's too long. Anyways, all right, so we did alpha radiation, where an alpha particle is given off, which is 2 protons and 2 neutrons, basically the nucleus of a helium atom. Remember, that was very low penetration. It doesn't even go through a piece of paper. Beta radiation, beta plus, beta minus, that is a little more penetrating. It can penetrate a couple millimeters into your skin, but it can get blocked by like little thin sheets of metal, like aluminum, or even like little thicker sheets of plastic. Now this one, gamma radiation. Gamma is energy only. Gamma rays. It's type of electromagnetic radiation, just like the light. Light is a type of electromagnetic radiation. UV rays. Well, it's a different type of energy rays called gamma rays. So it's no particles. It's no electrons. It's no positrons. It's no alpha particles. So this is where it usually follows alpha or beta decay. So like say uranium-238 decays, gives off an alpha particle. It then needs to release energy, and it does that through gamma rays. Now these are highly penetrating, and it's called ionizing because they're powerful enough to knock the electrons off the atoms in your body, creating ions. And those ions can wreak havoc in the body. So this is the most dangerous type of radiation. Remember, no particles, only energy. All right, so hopefully you guys understood this. Hopefully you took some notes because there's going to be a quiz coming up right now.